In order to get going with our analysis, we will have to consider something really important. It's the distance between two critics. So let's say that we have here also two movies, first being on x-axis to Pre, and on y-axis the snakes on the plane. And let's consider, let's say, two critics here, one being Nick Lazal and the other being Claudia Puig. So Claudia's grades are, or ratings are 2.5 and 3.5, and Mick's are 2 and 4. So how do we see how similar they are in their ratings? For that, we will have to use the Euclidean distance. So what we'll be doing is we'll be drawing a bunch of right triangles here on data and using the Pythagorean theorem to measure how far the critics are from each other. So for instance, the difference along the y-axis here is 0.5, and the difference along the x-axis is 0.5 as well. So that tells us that the difference between Mick Lazal and Claudia Puig, namely their distance, the distance between them, is 0.5 squared plus 0.5 squared. Those two sum, then square root taken from them, so it's 0.707. This eventually means that we'll have to be drawing a lot of right triangles. There's going to be a right triangle between Toby and Mick Lazal, Toby and Claudia Puig, and so forth. So all the combinations will have to be calculated in order to get to know how far everyone is from everyone. But there was one important simplification that we did right here. This was, we only considered two movies, Dupree and Snakes on the Plane. That's the reason we did it, was we wanted to really get a nice two-dimensional display here going. So we only knew the Pythagorean theorem so far. So what we'll end up with is, let's say that we have two users. So one user is named A, and the other one is named B. And their ratings for free movies this time are 5, 1, 0, and 1, 4, 2. Now the question is, how similar are those two people in their ratings of the movies? Let's find an answer to that question. So this here is our three-dimensional coordinate set. So this is x this time, and this is y, and this is z. So our first point is 5, 1, 0, which is this point. This is the point A. And our second point is 1, 4, 2, which is this right here. This is the point B. And how to measure their distance? Well, let's at first shy away from that z-axis. So let's draw only the x and y-axis. And these are indicated in bold here. So we're looking at coordinates 5, 1 and 1, 4. This we actually already did. So what we can do is draw a right triangle. The difference along the x's is 5 minus 1 is 4. And the difference along the y's is 4 minus 1 is 3. So now we have 4 squared and 3 squared. And we have to sum them together. It's 9 plus 16. The sum is 25. And we take a square root. And voila, our distance along these lines is 5. Okay, but we're not done. We have yet to consider the z-coordinates. What we do next is we go into 3 dimensions, and we take already, this was A, this was B, so that's this distance 5 here already as well. And we're going to add now, and we're going to add to it, like build a second right triangle. So remember, these 3, 4, and 5 gave us the first right triangle. But now that we're in the third dimension z as well, we're going to take this straight line 5 here, then take this straight line 2, that's the difference along z-axis, because 2 minus 0, sorry, 2 minus 0, yes, is 2. So the difference along z-axis is 2. And we're going to get a new right triangle. The sides are 2 and 5. And we do 2 squared plus 5 squared, so the same Pythagorean theorem all over again. And it's 4 plus 25, it's 29, square root of 29. And here it is, 5.39. So if we wanted to know, there are two people, one rated movies 510 and the other one rated them 142, how different they are or how distant they are from each other. The distance, the Euclidean distance, so to say, is 5.39. So, and it turns out that if we have 4 movies, we do the same thing. We can't draw it anymore, but we can still do the math. We can still do the Pythagorean theorem all over again. Let's go over that one more time. So the question was, how similar are those two people? The answer was so that took a square root where we did the x's subtracted squared, the y subtracted squared, and the z subtracted squared. So naturally, if we have 10 movies, it's just the 10 times the subtraction and squaring and all under the square root. So, and the answer here was 5.39. Now you might ask, as the question was how similar they are, the answer was how distant they are. Is this this is not the same thing, right? So let's move from distances to similarities. Our distance was 5.39. What if we do 1 divided by 5.39? How does that work? That works in such a way that if the distance is very big, let's say the distance is 1,000,000, then the similarity will be 1 divided by 1,000,000. Will be very small. So once again, if the distance is very big, like 1,000,000, the similarity will be 1,000,000th, which is very small. There is one problem though. What if they're extremely similar, like they're the same? Then the distance is going to be 0, and 1 divided by 0 does not compute. So that's why we do, for calculating the similarities, not 1 divided by that Euclidean distance, but we do 1 divided by 1 plus Euclidean distance. Note that we haven't taken the square root here, so that one is missing. But we'll let that just slide, because we can do such a thing. It's a simple, it's a little bit of a modification of the Pythagorean theorem, but it's not that important because it basically still gives the same thing or something very similar. So once again, our distances were Euclidean distances used by the Pythagorean theorem. Our similarities are, well, they are the reciprocal values of 1 plus distance. So these give us the similarities. But let's go a little bit further. Namely, there are very many different similarities that can be defined. And one that particularly helps us out here is correlation similarity, next to the Euclidean one. So what we do is, we've done a different graph. On the x-axis there are Mick-Lazal's grades, and on the y-axis Gene Seymour's. And what we've done is we've put all the movies here. So for instance, Just My Luck gets 2 from Mick-Lazal and 1.5 from Gene Seymour, and so forth. So we've drawn all the movies down here. Remember, before we just had 2 movies and we looked at distances between critics, and then added actually 3rd and 4th and 5th movie just in the progress. We wanted to do that as well. But now we have 2 critics and all the movies they've watched together. So these are 5 movies that they've both watched. And now what we do is we calculate the correlation. And remember that correlation was really the same thing as putting a simple linear regression line through the data. So this is like, it shows how those grades move together. You can see that this line describes that the higher the grade Mick-Lazal has given to a movie, the higher it has also been for Gene Seymour. So they're kind of moving a little bit together, not very well. So we can see that that R here is 41% correlation coefficient, and this is the line that was produced. And so they're not moving very well together, but still there is a correlation there. So this we can use for similarity as well, because you remember correlation went from -1, which was moving to the opposite directions, to 0, to +1. So really, the closer it is to +1, the better it is, the correlation. Actually, something we omitted from the last talk was that the last thing we looked at, this Euclidean similarity, this also went somewhere in a similar way. So it went from 0 to 1. We implicitly said that, but didn't write it down explicitly. So now we have this correlation similarity. And let's take a look at another one even. So here you see that are two different critics, Jack Matthews and Lisa Rose. And what we see in their cases, that this R squared is R is better. It's 0.75, the correlation coefficient. And the line really describes the data better, so it's a better hit on those data points. But there is even one more further suggestion to be made from here. You can see that although they are rating the movies in a similar way, the grades of Lisa Rose are somewhere between 2.5 and 3.5, whereas the grades of Jack Matthews vary from 1 to 5. So this really tells us that Lisa Rose kind of has the similar taste, because the R is high, so 0.75, but she's kind of her grades vary very much less, whereas Jack Matthews gives both 1s and 5s in there. So this is actually something that's very good about correlation similarity, as opposed to that Euclidean one, because if someone is like systematically putting lower grades or varying less, then correlation similarity picks that up. But on the other hand, the Euclidean similarity wouldn't discern that thing that well, so it would perceive as those two being more distant from each other, these two critics. We'll see actually that still there is a very high unison that these two distances will be making in our final predictions, but it's worth to try both of them.